All right, now let's talk about some consumer loans and amortization. Amortization. I have a struggle saying the word. Anyway, so in this lesson, we're going to talk about some common consumer loans. Consumer loans meaning we're the customers, and loans that we take out for different things. We're going to talk about amortization, what it is, amortization payments and schedules, and of course, common mistakes and key takeaways. So let's get into it. So, consumer loans, as you know, consist of like auto loans, mortgages, your student loans, credit cards, any type of financial product that you actually go to a financial institution. You say, hey, I need this money. They give you the money, they charge you interest, and you pay back, you make payments. You make regular payments, right? So it's sort of like an annuity because a lot of times the payments are consistent. They're the same across the board. They're every month. Most consumer loans are going to be every month. I think it's very rare that you see it. Like with my mortgage, we'll pay like extra payments, that type of thing, but it's still due every month. Okay, so that's the same thing with credit card and car payments. So, but it fits just like a annuity. So, if you have not seen the videos on annuities, go and watch that, and this will make more sense once you see that because we're going to be using the exact same tools and concepts in here. But so regular periodic payments. You have a future value, the amount you owe plus any interest, right? They tell you up front what you're going to borrow. There's an interest rate, and then there's a number of payments. All of these things fit the annuity, but the most important part is that they are regular payments. Most of them, again, are going to be monthly. So, when your loan payment, whatever loan payment you have, when that loan payment includes principal and interest together, that is called an amortized. It is amortized. That's what it means. So that means that that payment is amortized because it's not just a one-time thing. It doesn't just include the principal. You're not just paying back the principal. These financial institutions are actually charging you a fee, which is the interest, to borrow money from them. And so when you have the principal and the interest, that is considered an amortized payment. So it's your loan payment plus the principal and interest. When you're doing consumer loans, if we're honest, you know how much you're going to borrow and you know how much the interest rate is. But sometimes we run into additional questions like, how much are my payments going to be? When you go to when you go get a car, they'll tell you, hey, I can lower your payment. Like they suck you in with that. But there are other questions that we normally have around consumer loans besides how much is the payment going to be? How much am I going to be paying in interest? You should be asking about how much you're going to be paying interest. How much, if I make a payment, how much is it is going to principal versus what's going to interest. And a lot of people get messed up because I've heard of school loans and they're like, yeah, I'm making payments. Hold on, I dropped my pen. Hold on. I'm making payments, but my payments aren't even enough to make a dent in the loan. Well, that's because they don't realize that this is how much my payment is. They haven't calculated how much goes to the principal, how much goes to the interest. That is very important. So think about some other questions that you might have had with your consumer loans. And I'm hoping showing you this, you get an idea. Now, again, remember there's CPAs, there's calculators, you have AI tools. There's all these tools out there that'll give you this information, but going through this class, you need it for your degree, and you kind of get to see what's going on. So how much will my payments will be? That's normally the main question, because this is like consumer loans are almost like annuities, where they're pretty much an ordinary annuity. Again, go back and watch the video on annuities, and this will make so much sense. You know how much you're borrowing. That's really your principal or your present value, right? And so if we want to know how much we're going to be paying, we can actually take this formula and solve it for payment. If you take all of this here and move it over here by doing division algebra, you actually come up with a formula for the payment. So see, we took that part and we divided it. So if I go back, we're just going to take this part and divide it. And when you divide it on both sides and you simplify it, do a little algebra, you end up with this nice little formula over here that helps you determine what you have to make for payments. So a loan of whatever dollars at an interest rate I per period may be amortized in n equal periodic payments of PMT dollars at the end of the period. AKA, basically what that means is we can calculate a payment that includes your principal and your interest together. That means it's amortized, and then we can give you this loan, and these are what your payments are going to be. So just like with annuities, your payments at the end of the period, your interest rate is your rate divided by the however many compound periods it is, and then your N is the total time period. So the compounding periods times the annuity. Now, because these are consumer loans, more, I want to say majority of the time, I don't want to like give a number, but a very high percentage of the time your payments are going to be monthly. It's very rare that your payments are something different unless you have a special type of financial product. So, another good question. What is my remaining balance? Okay, I've made so many payments. I've made 50 payments. Now, how much do I owe? I've made 10 payments. Now, how much do I owe? There is a formula for that. So, if the loan can be amortized, meaning you can calculate a payment that has the principal and the interest together, you can actually figure out what the remaining balance would be for that particular loan. So, this is what the formula looks like. It's very extra. But again, there are financial tools behind the scenes that do this. Remember, we're just learning it so we have an idea of what's going on. I don't like hearing stories about people like, well, I didn't know I was making this payment and it was only going to the principal, or it was only going to the interest. I didn't know that I was making this. I've been making payments for years and I haven't put a dent in what I owe in my loan. This is what's happening behind the scenes, very high level behind the scenes. This is kind of the foundation of what's happening. Now, one of the things I want to point out about this formula, it gives you a reasonable approximation as an individual of what's going on. But when it comes to financial institutions and the banks, they have to be exact because they get audited. They have to account for every penny. So you'll see some adjustments that are made because you can't avoid rounding. Rounding happens. But for us, individual consumers, this actually gives you a reasonable approximation of how much your remaining balance is. And then there's calculators and other tools out there that will also help you determine, what do you call it? How much your payment is remaining and how much of your payment went to it can do all of that for you is basically essentially what I'm trying to say. But this kind of puts it in your hand. What was I going to say about that? Because the financial institutions have to be exact, that's where amortization schedules come into play, because they're going to show you exactly from beginning to end what your payment schedule is going to be, because they have already calculated it. That way it shows a little honesty and transparency up front and saying, hey, this is what we calculated. If you make these payments, this is how much is going to the principal, this is how much is going to the interest, and then these are going to be your balances at the end of that. If you go and look at your school loan payments, if you go look at your mortgage payments, I don't know if credit cards do it. I guess they have like a little chart, but really your school loans and like mortgage payments, car payments probably do it. You can actually find like a type of schedule. So below, this is just an example of, I think it was, of a loan of $8,384. They made a down payment. And then so this $7,184 was the remaining balance that was amortized, meaning they created a payment that covered the principal and the interest, monthly payments, 12% interest for 4 years. And then this schedule just kind of shows you, okay, this was my beginning. And then when I make a payment, this amount went to the interest, this amount went to the principal, and then this is what was remaining. Now, if you notice, the interest is what goes to the financial institution because this is what they're charging you. So the only thing that gets subtracted from the principal is the amount that you pay to the principal. Okay, that's why it's very important when you're making loan payments. You have to know, okay, I made this payment. Now, if you would have seen more coming to the interest and less to the principal, that's why your balance is not moving as fast. Normally, when you get mortgages, like when I first bought my house, you're paying more in interest because that's just how it works. But over time, as you make more payments, And for me, we double up on payments. So then you end up putting more money to the principal. When you put more money to the principal, you pay less in interest. So that's the idea. There are so many strategies that are out there to help pay off the loans faster if you have the ability to do them. All right. Let's start working through just some examples. And I just tried to pick some really small examples. And then what I'll do is on my paper. So let me switch this. On my little paper here to the right, I'll fill in some details. I won't do it on all of them because these are going to repeat, but just so you can see how the formula works. So this one says in October 2024, Zirconia Capital Bank advertised an auto loan rate for a used car of 4.5% interest for a 5-year loan. You want to buy the used car for $12,500. It's not bad. Find the amount of your monthly payment. So we have the formula, right? So what I'm going to do is we're looking for the payment. So our present value, or what we started with, we're going to borrow $12,500. Our rate is 12.5. Our rate is 4.5%, right? But we're going to convert that to a decimal. Okay. And then monthly payments. So M is 12. And then what else were we looking? Oh, and your time is 5 years. Now, again, if you have not watched the videos on the amortization, on the annuities, go back and watch that so that this will make more sense. When we're doing the I, remember to calculate the interest rate, that's your R over N. So 0.45 divided by 12. And then your N is M times T. So that's going to be 12 times 5, which is going to be 60. Hold on, let me open my iPad is kind of wobbly. Hold on. There we go. Scoot over. All right. iPad was kind of wobbly. So now when we plug it into the formula, plug and chug, right? So do I want to write that? Yeah, I'll go ahead and since I'm on my paper, PVI divided by 1 minus 1 plus I to the negative N, right? Okay, cool. So I'm going to plug and chug. This is going to be 12,500 times 0.045 over 12 divided by 0.045 divided by 12, right? And then divided by, what do we got? 1 minus 1 plus, same thing, the interest rate, 0.045 divided by 12 raised to the negative 60, right? And that's just following the formula, okay? That's just following the formula. So I'm going to move this up now that I've substituted everything. The hardest part is identifying your pieces that you need and then making sure you use the right formula. So we needed this for the formula, we needed the I, and we needed the N, okay? Because that's in the formula, okay? And then that'll give us the payment. So that's really the hardest part. So now that we've substituted in those pieces, now we just have to do the math. So if I do the numerator first, when you're in your calculator, put this in your calculator first and then multiply it by the 12,500, you should get 46.875. Okay. In the denominator, you're going to take this 0.45 divided by 12, add 1 to it. When you do that, you should get 1 minus 1.00375 to the negative 60. Okay. Now in your calculator, take this, do this first, 1.00375 to the negative 60, and then make sure that I wrote that right, to the negative 60. There we go. And then take 1 from that. Okay, so you're going to do this first, and then you're going to subtract 1. When you do that, you should get 0.20114768. And then when you divide this, go ahead and do the division, you should get 233.0377405, which is approximately 233.04. So this is the amount of your monthly payment. Okay, for each monthly payment. Each monthly payment over the span of 5 years. Okay, so that's how I substituted it. And then when you do the math, that's what you get. Easy? Good. Let's do another one. Here's an example of one with a mortgage loan. So suppose the same bank offers you a 30-year fixed mortgage rate of 3.68%, which that's really good. I wonder what year this is, because y'all know the rates are up in 2025. No down payment is needed. For a home price $225,000, find the monthly payment needed to amortize this loan. Remember, it's amortized if you can come up with a payment that includes the interest and the principal. That's what makes it amortized. So let's see. It's $225,000, right? The rate is 3.68%. Look at my notes. Yeah, make sure that's right. Monthly payments, right? And it's 30 years. And then our I, I'll do it right here. Our I is R over M. Okay, let me getting in a bad habit of assuming this is 0.0368. Remember, we always want to convert those to decimals. So your I is R over M. So that's going to be 0.0368 divided by 12. And your N is M times T. So that's going to be 12 times 30. So that's going to be 360. Okay. So now let's substitute what we know into the formula. So our payment is equal to present value times I divided by 1 minus 1 plus I to the negative N. So that's going to be 225 times 0.0368 divided by 12, right? All of that divided by 1 minus 1 plus 0.0368 divided by 12. And that's to the negative 360. So far, so good, right? We plugged everything in. Remember, the hardest part is identifying your pieces and getting the right formula. But once you get them identified, you just pull the pieces you need and substitute them into the formula. Okay, so you have everything that you need. So let's go and do the math. So in your calculator, do this first and then multiply it by that. When you do that, you should get 690. I know, surprising, easy number. And then down here, do this first and then add the 1. Okay, so when you do that, you should get 1 minus, what did I get? 1.00306667 to the negative 360. Okay, so now in your calculator, do this part and then take 1 minus that. Okay, when you do that, so you still have 690 on the top, you will end up with 0.66789,718. And then when you do this division, you get 1033.093151. And because we're dealing with math, this is 1 33.09. So this is your estimated monthly payment for this mortgage for 30-year, which that seems reasonable. Yeah, that seems reasonable. It is a little high. No, it seems reasonable. It just depends on, depends on what you're doing. 225. Yeah, that seems reasonable. I'm going to stay in my lane because I don't give financial information, but that seems reasonable. Okay, cool. Let me show that. So yeah, that's what we substituted. It looks good, right? All right, cool. Next example. All right, a personal loan, because we do take those. All right, it says you decide to apply for the following loan: $21,000, 2.75% interest for 10 years. What is your monthly payment? So as you notice, we're doing the same thing over and over and over again. So on this one, what I'm going to do, so your payment, sorry, I'm just going to identify the pieces. How about that? Because I think you understand how to do the math. So this is 21,000, right? My rate is 2.75%. So that's 0.0275 when we convert it as a decimal. It's a monthly payment, so that's 12, and my time period is 10 years. Okay, so my I is R over M, so it's going to be 0.0275 divided by 12, and my N is M times T, so that's going to be 12 times 10, which is 120. Okay, so all the pieces you need that, and you need that. And you'll plug that into the formula. When you plug that into the formula, so 21,000, right? And then 0.025 over 12 divided by, same thing, 1 minus 1 plus to the negative 120. So in your calculator, you'll do this first. Multiply that by 21,000. That's for the numerator. In the denominator, do this first. Add 1. And then raise that whole thing to the negative 120. And then take 1 minus that. When you do that, you should end up with $200.36 per month for your payment. Okay? That was example 3. I didn't label these. This was example 3. This was example 2. And this was example 1. So that was example 1. That was example 2. That was example 3. Again, because all these are like really the same type of work, that's why we're just doing it that way. Okay, so this one's example 4. So it says, find the monthly payment and estimate the remaining balance at the given time. Remember, we did go over that formula where you can get an approximate balance. So this is a 10-year student loan for $28,500 at 2.82%. And then they want you to find the remaining balance after 5 years. So let's do the first part of finding the payment. So your present value is $28,500. Your rate is 2.82%. These are monthly payments. Okay, these are monthly payments. Now I know it did. Yeah, it said monthly. Okay, good. I was like, did I put? And then the time period is 10 years. 10 years. Let me just do 10. Okay. Now this 0.0282, right? Yep. And so my I is R over M. So that's going to be 0.0282 divided by 12. And your N is M times T. So that's going to be 12 times 10, which is going to be 120. Okay. So we have our present value, we have our I, and we have our N. So now we can complete the PV times I over 1 minus 1 plus I to the negative n, right? So 28,500 times 0.0282 divided by 12 divided by 1 minus 1 plus, same thing, 0.282 divided by 12 to the negative 120. So far, so good. Okay, so we have all of our pieces, right? That we have all of our pieces in there. All right, so now put this in your calculator and then multiply it to the 28,500. When you do that, you should get 66.975. And then next, do this. So do the division and then add 1. And then when you do that, you're going to raise this to the negative 120. When you do that, you should get 1 minus 0.75452326. Okay, so now you're going to do that part, subtract that. When you subtract that, you still have 66975 in the top. Your bottom becomes 0.24547674. And then when you divide that, you get this number, 272.836446, which is approximately $272.84. So that's the amount of your monthly payment. Okay, I'll just label this as A. That's the first part. And then they tell you, they say, find the remaining balance after 5 years. So after 5 years, so 5 years that's going to be what, 60 payments, right? Because see, we started with 10 years, and if 10 years is 120 payments, well, 5 years is half of that, right? So it's going to be 60 payments. So after 60 payments, what's the balance in the account? Now that formula, let me show you, PMT. That's the one that had a lot of extra stuff going on. So 1 plus I to the minus n minus x all over I. Okay, yeah, that's the one with the extra stuff going on. We know our payment's not going to change. Well, not going to change. We have our payment here, right? Yeah, we have our payment. Oops, sorry. We have our payment right here. We know our I because we already calculated. The only thing that's going to be different is the X. So the X represents the number of payments that are left. So the N is what you started with, and the X is how many payments that you've already made. I said left. How many payments that you already made. Let me put that here. So the X is... make sure I'm telling you right. I believe it's the number of yeah, because you have to subtract the number of payments that you've already made. Let me make sure that I'm telling you right. Yep. So the number of payments that you already made. So you've already made 60 payments. So we're going to find what comes after that. So let's plug and chug, right? So it's still, we found that our payment was $272.84, right? And then we have 1 minus 1 plus our same interest rate, this 0.082 divided by 12, 282. Right? To the minus, our N was 120. So 120 minus 60. Okay? I know I'm running out of room. And that divided by 0.0282 divided by 12. Okay. So we plugged everything in that we see here. See the I, the N, the X, and the payment. You have the payment, the I, and then the N and the X. Okay? So now let's just do the math. So 272.84. The denominator, let me draw this. When I did the denominator, I got 0.00235. 1, 2, 3. The numerator, so do, of course you can do that, and then do that part first or second. So you end up with 1 minus 1.00235, and that's to the negative 60, okay? Because 120 minus 60, hold on. The 120 minus 60 is 60, and then the negative in front of it, okay? So now in your calculator, do this, and then take 1 minus that, okay? So when you do that, you have 272.84. 1 minus that at the top is 0.13136701 divided by 0.00235,000. Okay, so now in your calculator, put that part. And when you put that part in your calculator, you get 55.900,85532. And when you multiply that, you get 1525 1.98937. And that's approximately 1,551.99. Oh, sorry, put my comma in the wrong way, in the wrong spot. Now remember, this gives you an approximation. If this were a bank, they would give you the exact, okay? So there's our when we filled in the formula, okay, for the payment, we got 272.84. And then, sorry, that's kind of small, isn't it? And then when we found the number of payments after 5 years, and the X represents how many payments you've already made. Okay, so however many payments, which makes sense. So take that, 120 minus the 60, and then when you do the math, so you've, out of all the first 60 payments you've made, you started out at 28,500. Now they're saying you have 15,000 less left to pay. Okay, hope that makes sense. All right, cool beans. Repayment options. All right. So you notice with school loans, they offer you two different repayment options. Now on this one, I'm not going to do the math all the way out. On the interest paid, I probably will, because we're doing the same thing over and over again. If y'all are noticing, it's the same thing over and over again. So, but let me just write down some key stuff. So they're saying you have a standard, well, let's read it. A student education loan has two repayment options: a standard plan for 10 years, equal monthly payments, and then an extended plan for 20 years, equal monthly payments. So my loan is $35,000. $35,000 loan. My rate is 3.43%. That's the interest. These are monthly payments. Yep. Monthly payments, because it says find the monthly payment and the total interest paid under each repayment option. Cool. Because you want to know how much am I going to, which is the better plan, right? And then for the standard plan, I'll do T. The standard plan has 10 years. And then I'll put the extended plan. They want us to do 20 years. Okay. Your I, hold on. This should be 0.0343. Yeah. Okay. Your I is R over M. So it's going to be the same for both. But your N, you're going to have two different N's. So your N is M times T. For the standard plan, it's going to be 12 times 10, which is 120. I'll put standard. And then for the extended plan, it's going to be 12 times 20, which should be 240. Okay. Oh, extended, sorry. Let me put, this is standard plan, and this is the extended plan. So, all right, so we have the pieces we need, right? We have our PV, we have our I, and we have our N's because we have the standard plan. We have the standard plan. I guess I can, yeah. So we have our standard plan. And then we have our extended plan. Okay. So I'm not going to plug in. I'm just going to show you on the screen here. So if you look for the standard plan, you would take the 30. Keyed that wrong. That should be 35,000. You see that? It says 3,500. That should be 35,000. So I guess I do need to write it. So it needs, this one needs to be 35,000. Okay, I need to correct that. Times 0.0343 divided by 12, and then divided by 1 minus 1 plus 0.0343 divided by 12 to the negative 120. I'm thinking I just typed it wrong, so I'm gonna do the math really quick. So I'm gonna do this first, the numerator. Okay, so I'm gonna have 35,000 times 0.0343 divided by 12. Yeah, I just typed it wrong. 0.041667. And then I'm going to do the denominator. When I put it in my calculator, I'm going to do this first. Then I'm going to raise it to the negative 120. And then I'm going to take 1 minus all of that. Okay? So I'm going to do 0.0343 divided by 12. I'm going to add 1. I'm going to raise that to the negative 120. And I'm going to take 1 minus that answer. Yep. Okay. Yeah, I just typed it wrong. I'll fix that. 29001450. Okay, so then 100.04166667 divided by that number, and you should get 344.9540199, which is 344.95. Okay, so that is the payment. Okay, that's the monthly payment. Now they ask, so I'll correct that. Example 5. Let me make a note. Correct PowerPoint slide to that. All right. Okay, yeah. So that's the right answer. I just wanted to make sure. And then to find the total interest paid, take your $344.95 times 120 payments, because that's how much, that's the payment is always going to be the same, and there's 120 payments. You end up with 41,394. We'll take 41,394 minus what you started with, 35,000, and then that's how much you've paid. That's how much interest that has been paid. Does that make sense? Because whatever of this 41,000 that doesn't go to the principal, it goes to the interest. Okay, so that's how you find out how much interest you've paid, and I'll correct that on the screen. So make sure you write down this. Okay, the 35,000, not 3,500. Okay, so now let's look at the extended plan. Same thing. Yeah, I got to correct that on the extended plan. Let me look. Yeah. Okay. I'll correct that on the extended plan too. The math is going to be the same. If you notice, the only thing that changed is the number of periods, the 240. So if I'm looking at this, I can literally copy this. Oh, hold on. Save. Yeah. I'm going to copy this. Let's see. There we go. That's squeezing it in there, isn't it? But this is going to be, I'm going to put minus 240. Okay. Minus 240. Does that look like minus 240? It does not. Make room. There we go. Minus 240. Boom. All right. So the numerator is the same, but this denominator, when you do the math in your calculator, where'd it go? When you do the math in your calculator, you should get this. 0.49592018. Okay, and when you do the division, you get this 201,7293709, and which that's approximately 201.73. Okay, yep, I will correct that. So make sure in your notes you have the 35,000, not what's on the PowerPoint, okay? And then the total interest paid, same thing. Take your 201.73 times 240. You get $48,415.20. Subtract what you, the loan you took out, and whatever's remaining, that went to the interest. Okay, easy peasy. Easy peasy. All right, my favorite part. So the amortization schedule. An insurance firm pays $4,000 for a new printer for its computer. It amortizes the loan for the printer in 4 annual payments at 8% interest. Construct an amortization schedule showing the first 4 payments. Okay, so example 6. So this is the amortization schedule. This is, remember the little chart I showed you where it shows you all the payments? So if I write down the pieces, this is 4,000, and this is our last example. Yeah, this is our last example, so you can kind of see how it works. Your rate is 8%. Okay. It says annual payments. So M is going to be 1, which I'm glad because of the thing here. And looks like 4 annual payments, so that's 4 years. 4,000, 8%, 4 years. Yep. Okay, so your I is going to be R over M. %8 is 0.08, right? Divided by 1. Yay! It stays. It stays. That says, here we go. Where is it? Here we go. Yeah. Divided by 1. And then your N is M times T. So that's going to be 1 times 4. So that's going to be 4 because we're doing it for 4 years. So same thing that we've been doing this whole time. The payment formula, present value times I, divided by 1 minus 1 plus I to the negative n. When you do that, you plug it in, you get a payment of $1,207.68. Remember, your payment doesn't change for the life of the loan. We're just going to do the first four payments for this. Since there's only 4 annual payments, it works out. So we're just going to do 4. So it's great. But that payment will stay the same for the life of the loan. So now when you fill out the amortization schedule, you want to show, okay, here's my payment. How much of the payment, so you're going to have your payment. I'll do this in blue, right? So you're going to have your payment. And then you're going to show how much of the payment went to interest. And then you're going to show how much of the payment went to the principal. And then you're going to show that after you make the payment to the principal, you're going to show that the new, I'll just say the new ending balance at end of each year. Okay, so you're always going to start with a payment. You're always going to start with the payment. When you make a payment, some's going to go to the interest and the some's going to go to the principal. Whatever goes to the principal, you're going to take that and subtract it from what you started with. And then that's going to show you your new ending balance for that year. So every year you're going to make a payment. I made a payment. This amount went to interest. This amount went to principal. This is what my remaining balance is. Year 2, I made another payment. This amount went to principal. This amount went to interest. This amount went to principal. Here's my ending balance. And you're going to keep going through. So let's take a look at year 1. So in year 1, you make a payment, right? 1,000. Did I write? Oh, let me write down because I don't want to lose this. So I'm going to scroll this down, right? You're going to have your payment is always $1,207.68, okay? Yeah. Your payment is always $1,207.68. You're going to make a payment in the first year. Now, you want to calculate the when you make that payment, you want to say, okay, how much of that payment is going to go to interest? Well, you have to figure out, well, how much interest do I need to pay on this particular loan? When you're looking for interest, don't forget that because we're doing a year at a time, don't forget about this formula. Remember, I equals PV times R times T? Well, you're like, oh, but that's a simple interest formula. We're not doing simple interest. We're actually doing an annuity type payment, which is compound interest. Totally fine. Will that work? Yeah, 1 plus I to the T. So remember, that's the formula for compound interest. Now, remember that your compounding periods is 1. So everything's over 1. So when you're looking for the amount of interest paid, I won't even use this. This would be your formula because we're doing compound interest. See, I don't want to confuse you. Let me not confuse you. Because I don't want to draw it out. Your interest is always your present value times your rate times your time. That's how it's going to work out. I was going to do like future value, present value, but I don't want to create more work. Because it's an annual, because it's a single year, you can use interest equals I equals PVRT. That's the whole purpose of simple interest, is because you're calculating the interest for that 1 year. This covers the 1 year. So for your year 1, you're going to take 4,000 times 0.08, which is the rate, times 1 because it's 1 year. Okay, that's why this works out, because it's 1 year. You're only looking for the interest. If we would have done like the future value formula, you would have gotten the present value, the future, you would have gotten the future value, you would have gotten an amount, and then you would have to take the present value minus the future value, and that would have given you the interest. But because you're doing just for 1 year, using the simple interest formula works. Okay. You can do it the other way, but this works. So trust me, you're going to see, we're just going to go through it one by one. So after you say, okay, this is how much interest I have to pay on the $4,000. Now you need to say, okay, whatever's left over of my payment, $1,207.68, I'm going to subtract the $320 that goes to interest. When I subtract the payment from the interest, this is how much is going to the principal. Okay, because the financial institution is going to get their money. I hope that makes sense. And then your ending balance is $4,000 minus only what was paid to the principal. You don't get to subtract what went to the interest, because that goes to the financial institution. What goes to the principal is what you paid to the principal. Okay, so then this is your new balance at the end of year 1. So at the end of year 1, this was my balance. So now when we jump to year 2, you're not going to start at 4,000. You're going to start at 3,112.32. Okay, because that is your new principal. You made a payment. This amount went to interest. This amount went to principal. Subtract that from your principal. This is your new principal. This is what you owe right now. Okay, this is what you owe right now. So that's your principal. You're going to make another payment. Of this principal amount, how much needs to go to the interest? Take that times 0.08 times 1. Why can we do this? Because we're calculating the interest just for that 1 year. Okay, just the interest for that 1 year. This formula works because it's 1 year. You can do the bigger formula, and then you can subtract the future value minus present value to get the interest, or you can just do the interest formula. Okay, so trust me on that one. And then when you find that, you get $248.99. $248.99. You're going to subtract that from your payment. What I'm doing here is I'm keeping all the decimal places so that I can limit the rounding error. When I show you the final amount, it's the rounded amount. But as you work through the problems, keep the decimal places. So when you take 3,112.32 times 0.08, you actually get this full number. So if you get in the habit of keeping all the decimal places, only round when you enter your answer. Okay? So I hope you're with me. At any point, leave a question in the comments if I'm losing you here, so we can go. I want to make sure I don't lose you. So I made my payment. I'm going to subtract the amount that goes to the interest. Once I subtract the amount that goes to the interest, I'm left with the amount that goes to the principal. And then I take what I had, at the beginning, subtract. Notice I'm keeping all the decimal places. I subtract what went to the principal, and now my new ending balance is $2,153.63. So far, so good. Okay, now let's go to year 3. This is going to be my starting value for year 3. Okay, 2,153. Now, I kept all the decimal places. When you enter your answers, you can round. But as you're going through the schedule, to limit the rounding error, keep as many decimal places as you can. I try to say 8. Just with the math, these are the decimal places that I had, okay? So, yeah. All right. That's my principal. I'm making a payment. Notice the payments don't change. Your payment is the same for the life of the loan. Calculate the interest on this amount, keeping all the decimal places. I get $172.29. If that went to the interest, take the payment minus that so I know how much went to the principal. Notice that the payments going to the principal is getting higher, which is good. That's what you want. You want the principal to come down. Then my ending balance is what I started with minus what went to the principal. You don't get to subtract what goes to the interest because that's not yours. That goes to the financial institution. That's how they make their money. You only get to subtract what you paid towards the principal. The rest goes to the financial institution. So I'm left with $1,118.24. Now, my payment is more than what I owe. We don't want that. So it looks like we're going to have to make an adjustment, which that's okay. So let's keep going. You still have to make the payment because the financial institution has to get their interest. You owe them the interest. So you'll still make a payment. They'll just make an adjustment so that you don't end up, paying more towards the principal, because you only want to pay what you owe, but they're going to make sure they get their money too. Okay, so let me show you. So on year 4, I'm keeping all the decimal places, okay, just so that I limit my rounding errors. This was my principal. My payment is more than what I owe, but I still got to make the payment because that's what my loan said. That's the payment I have to make, and then I still have to pay them the interest. So take the principal times 0.08, and this is how much they get in interest. I still have to pay them that, okay, out of this payment. So now, if I take my payment and I minus the 89.46, I'm left with $1,118.22 as my principal. Okay, that's how much I have left to pay, supposedly, or that's how much that's going to go towards my principal. That's what I owed. That's what goes on it. So notice, see, there's some rounding differences. That's okay. And then when I take what the balance was and I minus that's 2 cents. You shouldn't owe 2 cents because I'm paying the full $1,118. I gave you $1,207. I gave you more than what I'm supposed to give you. Now, again, they're going to get their interest. So now we need to make an adjustment to the payment so that we don't end up paying more. So year 4, y'all see that? We ended up with 2 cents. It should be 0. So we're going to adjust the payment. And this is what the financial institution would do behind the scenes. They would adjust it, and then you would see it on your schedule to say, hey, your last payment is actually going to be a little higher to make sure that we get our interest and you don't pay more than the principal. Okay, because remember, of every payment, there's going to be an amount that goes to the interest. There's always a certain amount that goes to the interest. They're going to get their interest, and then they'll make an adjustment. So here's what happened. We're going to make this payment. Of this payment, $89.46 is going to go to the financial institution. It left me with the principal payment that went to the principal of $1,118.22. I was short 2 cents, right? So they're like, okay, let's adjust this payment so that nobody owes anything and we can close out the loan. So you're going to adjust your year 4 payment. That 2 cents, the financial institution is going to add it to your payment. So your last payment is actually going to be $1,207.70. Why? Because when we subtract our interest, we want to make sure that whatever you have left over is going to cover what you're supposed to cover and not anything more or anything less. So we adjusted your payment. We added the 2 cents to it. We subtracted what we get, the $89.46. That leaves you with the $1,118.24. And when you subtract that, right, you have 0. Okay. So if you were to go through and use the remaining balance formula, you would see differences too because of the rounding. But the final payments are going to be adjusted if there has to be, because there's always going to be some type of rounding where you have to compensate for it. So it's going to be adjusted. So I hope you go back and look at these, or look at this, rewind this so you can see how we went through all the payments, how we kept the decimal places, where we had to make an adjustment. Okay? Email me your questions. Put them in the comments. Put your questions in the comments. I got you. Okay? Put your questions in the comments. All right. So this is what the amortization schedule looks like. It matches everything we had. Okay. What you started with, your payment, how much goes to interest, how much goes to principal, your new balance. You make another payment, interest, principal, new balance. You make another payment, interest, principal, new balance. You make another payment, interest, principal. See how these match? You want them to match and then say, okay, you're done paying off the loan. That's your goal. That's your goal. And notice that you paid more in interest to start. You paid less in principal, but you ended up paying more. That's how it worked. Normally at the beginning of the loans, you'll pay more and then you'll pay less in principal and higher, unless you double up our payments and add extra payments, that type of thing. Okay. All right. Common mistakes for this section, this same common ones. Make sure your decimal is make sure your rate is a decimal. Check your compounding periods. For consumer loans, it's always going to be 12, but just make sure it'll say monthly payment, monthly payment. Know which formula to use. This is just like a ordinary annuity, these consumer loans, when you're making the payments. Go back and watch the video on the annuity so you have an idea. And then remember, keep as many decimal places as you can to limit the rounding errors, okay? And then don't round until you enter your final answer. Some key takeaways. The payment formula for amortization payments. Remember, a payment is amortized if it includes the principal and the interest together. That's what makes it amortized. And then the remaining balance formula. Remember, this formula gives you an approximation for the individual, for the consumer. Behind the scenes, financial institutions, they have to track it to the penny, because they get audited. They have to make sure they're not taking money from customers, making sure they're not misplacing. Like, every penny has to be accounted for. So they have a more, and remember, computers are doing all of this to the umpteenth power. This is just for individual consumers if you want to know what's going on. I hope that this was helpful, because I really want people to know what's going on. You might not like the math or understand the math, but at least now you kind of have an idea of, okay, this is what's going on my mortgage, my car payment, school loans, whatever. Okay. All right. Again, as always, you're going to be successful on your assignment. Remember, some questions may be easier or harder. Just follow the steps that we've had in this video. Feel free to come back and comment with any questions that you have. Write down the steps so you can see what you're doing. You notice with the amortization schedule and going year to year to year, write it down so that you can see what's going on, see what you're doing, keep your decimal places. And then remember, you can always reach out when you have questions, because I am always happy to help. All right, guys, I hope this information was helpful. Looking forward to hearing from y'all.